Welcome to 8-Bit Simulation. In this episode, Link Sword Upgrades. We'll be using Autodesk Simulation Mechanical to run a tensile test on each of his swords to make sure he wants to keep upgrading. But first, our video game challenge. Just show yourself playing Zelda for a chance at a great retro prize. We will start by modelling the wooden sword, white sword and magical sword in Fusion 360. Although these swords are shown in 3D, we will project a sketch of each so that we can work with a 2D model. With the wooden sword open in Simulation Mechanical, we'll need to clean up some of our lines. The lines will have to make up one body to enable 2D meshing. Deleting the lines that intersect and drawing new lines to close gaps will take care of this. With this done, we can right-click on the sketch lines in the model tree and choose to generate 2D mesh. Next, we will define the thickness of the sword to be 1/4 inch and then define our material. We have a special Zelda material library set up with the properties for the wooden sword created. We also need loads and boundary conditions. Selecting the nodes at the bottom of the hilt, we can choose General Constraints and check the box for TZ and TY to keep the sword from shifting in the 2D plane. The top nodes of the blade will be selected and have a prescribed displacement defined to stretch the sword. After defining our analysis parameters, it's time to analyze. You can see in the results that the wooden sword's factor of safety dips below 1 much before the white sword. It also appears that the shape of the magical sword causes some areas of concern, failing before the white sword. Checking out the stress results shows that Link might want to hang on to the white sword, even if the magical sword does twice the damage.